Hi, my name is Daniela, and today I will be explaining trigonometric substitution. Trigonometric substitution is used whenever you are trying to solve a complicated integral and it cannot be solved with regular substitution. So there's different instances where you would use trigonometric substitution. One instance is where your integral includes this format right here. During this case, u would equal a sine theta, and you would draw your triangle like this, u over a squared minus u. If you look, you would notice this looks a lot like inverse trig substitution. It's very similar, has almost the same setup, but you can't use regular substitution with this. Another example would be where your integral is a squared plus u squared, where u is equal to a tangent theta. Once again, you draw your triangle, and you have a over u, a squared plus u squared. Also, up here, it's good to know that a squared minus u squared is equal to a cosine of theta. And here, the square root of a squared plus u squared is equal to a secant theta. Okay. Now, next we have the integral of u squared minus a squared, and u is equal to a secant theta square root of u, a square root of u squared minus a squared, where a tangent theta equals u squared minus a squared. Okay, and then we are, my bad, this is u right here, and this is a. So a equals secant theta. Okay, so these are the different forms of trig substitutions that you can have. Reminder that it does not have to be exactly in this form. It can have a 1 on top. It could have various forms. But as long as this basic part is in your integral and you can't use u substitution, you try trig substitution. So, trig substitution is often not used on its own. We're going to show an example of trig substitution that has both trig substitution and regular substitution. So we have 1 minus x squared over x to the 4th dx. Okay, so first part is, we see this, it's in the form of a squared minus u squared. So therefore, we have x is going to be equal to sine theta. That is our first part. Now we draw a triangle, and we have that x over 1 square root of 1 minus x squared. Okay, we also need to figure out what dx is, and dx is the same thing as cosine of theta. So, now we use trig substitution, and we know that 1 minus x squared is equal to cosine theta as well. This is d theta. Okay, so we substitute back in. We have cosine theta times cosine theta d theta all over sine, this is power of 4, theta. So we substitute. So we did our trig substitution. Now we go down. This is the same thing as cosine squared theta d theta all over sine to the 4th theta. Okay, so let's separate this a little. So we got cosine squared theta over sine squared theta times 1 over sine squared theta d theta. Rewrite this as cosecant squared theta times secant squared theta d theta. here, if we look, we can use substitution, right? So we're going to use u substitution. So in this case, u is going to equal, oh my bad, sorry, this is cotangent theta, this is cosecant theta. Okay, there you go, cosecant theta. So u is going to equal cotangent theta, du is equal to negative cosecant squared theta. Okay, so we draw this in and we have u squared, so negative du. And then we take this out and we have negative u cubed divided by 3 plus c u cubed. So then we plug this in, so it's negative cotangent cubed theta divided by 3 plus c, which is equal to negative, and then our problem would look like this. This would be, this over this is cotangent, so it's going to be square root of 1 minus x squared cubed over 3x cubed plus c. And that is your final answer. So when doing this problem, not only do you substitution, trig substitution, you may also have to do regular substitution, and then once you're all done, you have to go back and plug in everything until it's back in terms of x. And right here, just to confirm, this is cotangent squared times cosecant squared, because cosine squared divided by sine squared is the same thing as cotangent squared, and 1 over sine squared is the same as cosecant squared. And that's how you do trig substitution.